Hello everyone, welcome back again to Bio Tutorials. In this video we are to talk about the overview of heat transfer. What is heat transfer? Heat transfer is a science that deals with the determination of the rates of such energy transfers. And heat transfer deals with systems that lack thermal equilibrium, and thus it is non-equilibrium phenomenon. So in heat transfer we have the three basic mechanisms: the conduction, convection, and radiation. So let's solve the example number 1 of heat transfer. A 10 centimeter thick block of ice with a temperature of 0 degrees Celsius lies on the upper surface of 2,400 cubic square centimeters slab of stone. The slab is steamed exposed on the lower surface at a temperature of 100 degrees Celsius. Find the heat conductivity of stone if 4,000 grams of ice is melted in 1 hour, given that the latent heat of fusion of ice is 80 calories per gram. So let's write. In order to solve this, we have to write all the given values. We have the area, which is 2,400 square centimeter, the thickness, which is 10 centimeter, and the change in temperature, 100 degrees Celsius to 0 degrees minus 0 degrees Celsius, and we get 100 degrees Celsius. We have the time, which is 1 hour, and by converting this into seconds, we get 3,600, and the heat transfer, which is mass times the length, given that mass is 4,000 multiplied by the L, or the latent heat of fusion, which is 80 calories per gram, and we get, by multiplying 4,000 to 80, we get 320,000 calories. And the heat transfer rate, which is given the equation Q, small letter q, or the rate heat transfer, equals the heat transfer over time, given that our heat transfer, which is 320,000 calories, divided by our time, which is 3,600 seconds, and we get the heat transfer rate, or the rate of heat transfer, which is 89 calories per seconds. Since we need to find the heat conductivity of stone, so by transcribing or transposing this equation to make it more convenient, as thermal conductivity is equal to rate of heat transfer multiplied by the thickness over its area multiplied by the change in temperature. Let's get back. We have the 89 as our heat of rate transfer. Yes, 89 calories per second over times 10. Yes, times the thickness, which is 10, over the area, which is 2,400. By converting this into centimeter, we multiply it by 100, and we get, by plugging this into our calculator, we get the thermal conductivity of 3.7 times 10 raised to 3 calories over centimeter second degree Celsius.